Hello everyone. In this video we're going to look at an example of a problem using the ideal gas law. So here we have a large cylinder of helium gas, such as that used to inflate balloons. It has a volume of 25.0 liters at 22.0 degrees Celsius and 5.60 atmospheres, and we want to know how many moles of helium are in such a cylinder. So the reason that we know to use the ideal gas law here is that we're dealing with four quantities: volume, temperature, pressure, and moles. And whenever we have those four things, we know those four things are related by the ideal gas law. The ideal gas law states that pressure times volume equals number of moles times the ideal gas constant times the temperature. And often on a problem like this, it's a good idea to write down everything that we know. What variables do we know? What variable are we looking for? So as we go through this problem again, we see that we have the volume of 25.0 liters. We have a temperature of 22.0 degrees Celsius and a pressure of 5.60 atmospheres. And we're looking for the number of moles N. A couple things that we need to think about here before we start plugging in. One is that we want our volumes to be in liters before we plug in. Here we already have liters, so we're fine. We also need to check our temperature. Our temperature must be in kelvins before we can plug it into the ideal gas law, and here we see that it's in degrees Celsius. But remember that temperature in Kelvin equals temperature in degrees Celsius plus 273. So we have 22.0 plus 273, or to the correct number of significant figures, 295 kelvins is the temperature of this helium gas. Our pressure is in atmospheres, and then remember that we have two possible values of the ideal gas constant. One is at 0.0821 liters times atmospheres over moles times kelvins, or 8.314 liters times kilopascals over moles times kelvins. And the way that we decide which version of R we want to use is based on what unit of pressure we've been given or we're looking to find. So here we've been given a pressure in atmospheres, and so we want to use the first version of R listed here, which involves atmospheres as a unit. So now we've identified the proper form of R. We have our volume, temperature, and pressure all in units that we want, so we can go ahead and plug everything in. So we have 5.60 atmospheres times 25.0 liters equals N, the thing we're trying to find, times 0.0821 liters times atmospheres over moles times kelvins, all times 295 kelvins. So there are a couple different ways that you can go about doing this. One would be to divide to get N by itself. The other would be to multiply out the numbers that we have right now. If we do that, though, we need to make sure to keep a couple of extra digits around. We don't want to introduce any rounding errors at the end when we round to the proper number of significant figures. So here, all the numbers that we have three significant figures. So if we're going to multiply at this step, let's say we're going to keep 5 significant figures so that we know that we don't introduce any rounding errors. And so on the left-hand side, if we keep an extra couple of significant figures around, we have 140.00 atmospheres times liters. And on the right, we have N times, and let's actually keep all digits here, 24.2195. Now we need to check our units. Notice that on the right-hand side here we have kelvins on top and kelvins on bottom that cancel out. So that leaves us with liters times atmospheres over moles. Now we're looking to solve for n. So we divide by that number on both sides. So on the right-hand side, everything cancels out except for the n. On the left-hand side, if we look at the units, we have atmospheres over atmospheres cancels, liters over liters cancels, and so our units are then 1 divided by 1 over moles, which is just moles, which is what we were looking for. And so then we do that division in our calculators. And again, referring back to the numbers that we started with, we want 3 significant figures in our final answer. And so then n would be 5.78 moles. Some things to keep in mind in these types of problems. First of all, what tells you that we should use the ideal gas law is that we're given 3 things and we're asked to find a 4th. So out of the set of volume, pressure, temperature, and number of moles, we're always being given 3 and we're being asked to find the other. We want to check our units and do any conversions that are necessary before we plug into the equation. So we want volume to be in liters, temperature must be in kelvins, and our pressure should be in either atmospheres or kilopascals, and n in moles. And then the final thing we need to think about is which version of the ideal gas constant R to use. And again, we're going to choose that based on the unit of pressure that we're dealing with.